This video shows the solution to an example of combined inequality. Learn how it is done here in Mathematics of Engineering. There are 5 types of inequalities, the first one of which is linear. By the name, the degree of inequation is 1, which means the exponent of the variable is 1. The second type is quadratic, which has a form where the variable x is squared. The third type of inequality is rational, which has the form with a denominator, analogous to a rational function. The fourth type of inequality is compound, which can come in 2 different formats. The first format contains 2 inequalities connected by and or or. The second configuration of compound inequality is a series of inequalities connected by 2 operators. The last type of inequality is absolute value, which includes a modulus. Each of these types of inequalities has a distinct operation to get solved. The first inequality example is 4 times the absolute value of 2x plus 1 all upon x less 1, and this is greater than 20. Analyze the inequation. The denominator shows that there is a rational inequality. And from the numerator, we also have absolute value inequality. Let's start the solution from the denominator. The denominator of x minus 1 shouldn't be 0 to avoid having an indeterminate form. So we can deduce that x should not be positive 1. This is then our first marker. From the numerator, the inequation is 4 of the absolute value of 2x plus 1, and this is greater than 20. Isolate the binomial in the absolute sign, so we have to divide the inequation by 4. The 4's on the left cancel out, and the constants in the right are simplified into 5. The inequation then is written as the absolute value of 2x plus 1 as greater than 5. To tackle the modulus, we identify the definition of absolute value, where the inequation turns into 2x plus 1 as greater than positive 5. Then also the expression is greater than negative 5. Next is to look for the values of x. So from the first inequation, subtract 1 to isolate 2x plus 1. This leaves us with 2x as greater than 4. The last step is to divide both sides by 2 to totally extract out x, which then turns into x as greater than 2. From the second inequation, subtract 1 on both sides, providing 2x as greater than negative 6. Again, extract out x by dividing both sides by 2, giving x as greater than negative 3. Have these 3 coordinates plotted on the number line so we can test each range. Again, the markers are with x equal to negative 3, positive 1, and positive 2. Having plotted the markers on the number line, where negative 3, positive 1, and positive 2 all carry a hollow dot, we can then start with the test. Starting from the leftmost range, from negative infinity to negative 3, we assume a number, say negative 5. Plug this into the inequation, making 4 times the absolute value of twice of negative 5 plus 1. Then the denominator has negative 5 minus 1. This is then compared with positive 20. Simplify terms and have 4 times the absolute value of negative 10 plus 1. all upon negative 6. The absolute value is then solved as negative 9. Take out the absolute value, making positive 9. Then we get 4 times 9, which is 36 all over negative 6, giving negative 6, and this isn't greater than 20. Thus, the range is not valid. The second range is from negative 3 to positive 1, so we assume x of 0. Plug this into the yin equation, making it 4 times the absolute value of 2 of 0 plus 1 all over 0 minus 1, and compare this with 20. The binomials are then simplified as 1 and negative 1. So take out the modulus to have 4 times 1 over negative 1, which in turn is negative 4, and this is not greater than 20. So the second range isn't valid either. The third range is between positive 1 and positive 2. Say we use 1.5. The inequation then is 4 times the absolute value of twice of 1.5 plus 1, all over 1.5 minus 1. Then compare this to 20. The left side is then simplified as 4 times the absolute value of 4 upon 0.5. The absolute value of 4 is positive 4. So 4 times 4 over 0.5 is 32. This is greater than 20. Thus, this statement is right. The last range is from 2 to positive infinity, and we assume x as 3. The inequation is then 4 of the absolute value of twice of 3 plus 1 all over 3 minus 1. This expression is then simplified as 4 times the absolute value of 7 all over 2. Take out the modulus and still have 4 times 7 divided by 2, which is then 14. 14 is not greater than 20, so this range is not valid again. Having to exhaust all ranges, we can say that the answer for the inequality is from 1 to 2 exclusive.